Hello guys, welcome to another video. Today I've got something different other than switches. This is a HyperX Quadcast S standalone USB microphone. I paid £17 and I think these go for around £100 new. So if I could get this going, it might be better than the microphone I'm currently using now. So fingers crossed I do. I have seen a disassembly video and it looks kind of complicated, but I hope I could get into it fine. So so it's USB-C port, and if I plug in my ammeter and look what happens, it's 5 volts going in and out, 4.9, and it shuts off. When it does that, that usually means that there's a short. So come back on, plug it in again, doesn't draw anything and just dies. So there's definitely something wrong with the motherboard, which is good. So let's get in there and have a look. Okay, now once I've done that, I think they said I have to pull this out. So let's see if I could do that. That is quite tough. Might have to get a pry tool in there just to pry it out. Think it's coming. There you go. So it's just simple pulling it off its main spindle. So that's good. Now I think we have to disconnect the top, and I think they did basically the same thing, but they heated up the round there because there's glue. So let's heat it up first. Got it at 150 degrees, so it shouldn't melt, and this is metal anyway, so should be okay. It's coming. Oh god, that was glued down. Yep, there you go. And I've destroyed, I've ripped the connector off the board. Great. Absolutely great. Damn it. Have I ruined it? Bit too aggressive. Might be alright. The traces are not damaged, it's just lifted off. Okay, well let's sort that out first before we go any further. That's the inside of that. Oh, I can't believe I yanked on it too hard. Touch, that's the touchpad there, look. So you just touch that and it will recognise that it's been touched. But let me see if I could push this back in. Well, I completely damaged that side connector there, but I think, oh, I've damaged all the connector. Let's just break that bit off. My tweezers are stuck together. There you go. So, was that any good? Is that a damaged trace? Yes, it is damaged. Alright, I'm going to have to check with the multimeter to see if we've got any readings. That last trace will need to be repaired. Oh, I can't believe I've done this. Look at that, I've destroyed it even worse than what it started with. What I'll do is a continuities test instead. So if it beeps, we're all good. So that's not all good. That's not connected. This one. Oh no, wait. The resistor. So this one is not good. It's not connected. This one, connected. The next one, connected. The next one is connected. Next one after that goes to, don't know where that goes. There, that's connected. And the last one, so it's just one trace that's damaged. So we're gonna have to quickly repair that. So let's go under the microscope and let me quickly repair it, try and make it more solid. As you can see here, these are all lifted off, that's my fault, and this one is actually broken. So what we're gonna do is put a wire from there straight to here so it bypasses that break. So scrape some away to expose the copper. That should be good. And now let's get some solder on it. Alright, that's soldered on there. Let me just tear off the excess. There you go. And you can see it's soldered. It's soldered on. So if I nudge this, well, let's check for continuity anyway. It's on continuity mode, so let's see if it beeps now from this resistor to the pin, the first pin. Yep, there you go. Lovely. So that is soldered on. So let's put some solder mask on that and make it look tidier and a bit more secure. Oh, I thought I broke all that off. Obviously there's still some on there. Okay, let's give that a little bit of heat just to see it change colour. It should be more solid when I heat it up. There you go, it's gone more pale. Oh, okay, there's still some UV mask underneath there. So I have to solidify it a little bit more. Still not fully cured underneath. I think that will do it. I don't know if that's cured there or not. Yeah, it is. Okay, and that's done. So hopefully that should keep it held down a little bit. I have, however, ripped it off the board at the side there, but it's a shame. I'll only have to plug it in once and leave it like that, and it should be fine. Right, okay, so that's that done. Let's put it back in. Okay, so that's that done. Now back to the main base. Now, I think I saw somebody just take this out by memory. Don't really want to ruin it. So we'll leave it there for a minute because I don't know if it's actually attached to anything. Let's just unscrew these screws at the bottom. So there's 3 screws. Okay, do we just pull it now? Push it? Push it through? Pull it? I don't know. They said about these as well, so let's undo these nuts. These nuts. I'm going to use something to poke it through. Ugh. I swear they said that this whole thing comes out. This whole clear casing comes out. Do I have to take that? Yeah, I think I have to take this off. Does this button come off? Yeah, it must do. Alright, let's try and pry it off. Oh, there you go. That was easy. Now it should come through, right? Let me try and push it through again. Yes, there you go. Right, the foam is not coming with it. It's kind of stuck. So why is the foam not coming with it? We need to take the foam out first. It's attached to the cable. Right, okay. It's glued onto the cable. I'm going to have to tear it slightly, which is annoying. It should be okay. Now we can take the foam out, surely. Or we'll leave it in there even and just pull this out. Yeah. Okay, we'll leave the pop filter in there. That's good enough. Not damaged it. Everything else is damaged though. So that's just now a tube. Oh, okay, well, that's part of the nut, I think, or at the side here it was. Yeah, it's for that bit there. It's a bit of a dodgy thing, but okay. Now, how do we get into it now? Pull this out. Okay, yeah. Oh, okay. I've got to guess which one's got the short on it. Is it the main board? Or is it this board? I kind of want to get to this board first, because this is where the power goes through. So how can I open this casing up? Can I open the casing up? Does that separate a little bit if I squeeze? No, that's a solid unit. Okay. Huh. I could just all disconnect it from here. But how am I going to know which one goes where? So I can't pull it out because of that reason. Right, I'm going to have to take a quick picture to see where all these cables went, and then I'm just going to have to disconnect them. So I'll be back in a second. Alright, here we go. Just going to have to start trying to disconnect them. Okay. Right, so let's start off with this board. So that's a bit dodgy there. Oh, okay, that's what the nuts are for. Right, okay. The nuts is to hold this thing down. So what I'm going to do is just put the ammeter in there now, see if this has got the short or if it's that got the short. If it cuts out when it's plugged into this alone, then you know that it's this board. So let's give that a go. Alright, does it cut out? It does, so it's something to do with this board. Well, that's good to know. Could it be a little capacitor, or could it be this main chip down here? So let's go under the microscope and check for shorts. Actually, we'll inspect the board first, then we'll check for shorts, and then we'll go from there. Starting off of the underside where the potentiometer is, we're just going to inspect the board and see if we see any signs of explosions on this side of the board. Nope, there's nothing here that I can see. Anything look dodgy? Not according to my eyes. Alright, now flip it over. Anything here? See, that does look a bit wet there, doesn't it? But I'm not sure what that is. That chip looks a bit wet. Why is that so wet? Let's carry on looking. It all looks fine. Looks okay. No. Okay, so the next step is to check for shorts. Now, because this potentiometer is on here, it's not going to keep the board level. So I'm going to have to try and find something that will keep it level. 2 seconds. Right, I found something. So we're into continuity mode, and now let's check for shorts. So I'm going to have the black probe on ground. Just check this one. Nope, that's okay. This one. That's okay too. Just go around checking the capacitors, that's fine. This one. Nope, that's fine. Should that be ground? That's a lot of grounds. That's ground, 100%. But these two should be ground? They don't look like they should be. I don't think they're supposed to be ground. Alright, let's bear that in mind. Let's check these ones. As I can't really find anything on the board yet other than those two pins being short, I'm just going to take off this controller chip. I've googled the chip and it's a controller for everything else. So I'm just going to take that off and see if the changes change. See if the short goes or something. Right, now let's test to see if those data pins are gone. So these two here are the ones that were shorted. No, where is it? Oh, these two here. See if they're still short. And if they are, I'm going to inject voltage into it. So let's have a look. Nope, there's no short now. Well, there wouldn't be, would there? Because there's no chip for it to go into. So is it just that chip that was faulty the whole time? Let me plug in the ammeter and see what happens. Right, let's see if it cuts off. Nope, it doesn't cut off. But it doesn't register that nothing's connected. I reckon it's that main chip there, you know. This one that does the voltage regulation and everything, I think. Let me have a look on the data sheet and see what it actually says. So apparently this is a four hub speed low something controller. So yeah, it's the main chip. It's got voltage regulators in there. It's got power failure detection and all that stuff. So I think it's like the main circuit of it. So I'm gonna order one of these chips up and let's see if that fixes it. I guess I'll come back in a few days once it's arrived. Yeah, let's get this chip off. I'll get you under the microscope for it. This should be a lot easier to take off now. Okay, that's off. My microscope went out of focus. Brilliant. Add a bit of leaded solder to these leg solder pads. Lovely. Board's moving now. Right, let's tin up this new chip. I've got loads of them. I think I've got a pack of 10. Actually, I'm not going to tin this one because there's plenty of solder on there. It's fine. So if I just literally rest the what happened? Oh, there you go. It moved. I must have moved it. So if I rest that just there, come in with the heat, and let's just go straight for it. Okay, I think we're good there. Just got to apply a bit of pressure and then heat it up. If the board would stay still, which it's not. Just going to wait for this to cool down and then we're going to plug it in again, see if it shuts off. I think it's cooled down enough now. I have low hopes for this. Here we go. Oh, wow. There you go. Staying on. So it was that chip. It was the first one I thought all along. Damn it. Spoke too soon. Oh, oh, is that just a dodgy port now? No, it's looping. Oh, no, it's not. Is it dodgy port? I have no idea, but that's definitely behaving differently. It's not drawing anything, which is good, and it's staying on. Let me check those data lines I had before. Do you remember when it was measuring like really, really low on diode mode? Let's have a look at them. So if I go to my multimeter, go back into diode mode, red on ground, and is it, I forgot which one it was, these two, wasn't it? Yep, 0.39 volts. There you go. Before it was really low. And same with this one. This was reading zero point 0.4. So I think it's good. 0.391, zero point 0.4. Yeah. So it was this chip. Do we get any lights or anything? Nope, we get no lights. It did draw something for a split second, and now it's not. Let's try the other way. Nope, this way. Nope, maybe it needs to be connected to a PC. Yeah, that's probably it. Let me try plugging it into my laptop quick. No, it's not drawing anything. 5 volts, 000 amps. Right, excuse the high exposure, but I can't bother to set it up right now. I've just found something. I was measuring around. I was like, why is there no 5 volts? I could be completely wrong, but I thought, okay, let me follow it. So if I follow 5 volts backwards, I was like, okay, it goes to this pin here, so it's not going to go anywhere because that goes from a cable to a cable. But I thought, okay, these are just capacitors and they're fine. If I go through the resistor, I was like, okay, what's 2R2? And I Googled it and it's 2.2 ohms. I thought, okay, let me measure that in ohms reading. So if I go over to my phone quickly and if I get my multimeter and I go onto that resistor, it's reading, look at that, 326 ohms. That is way too high. And I'm only getting zero point 0.8 volts to the 5-volt rail. So I think that this resistor has blown and it's not allowing much voltage through it, current. So it's not getting enough voltage. So that might be our next issue. So I've got to look for a 2.2 ohm resistor, or even if I think maybe a 2 ohm resistor might work. And yeah, let's get replacing it. The only issue is it's right next to, oh, yeah, it's right literally next to the port there, so I've got to be careful not to melt it. I'll just use my soldering iron and try and knock it off basically. But yeah, I'll be back once I found a new resistor. I didn't manage to find a 2.2 ohm resistor, but I have just got a zero point 0.5 it was measuring, so it's probably a 0 ohm. I'm sure that two ohms isn't going to make much of a difference, right? So let's try and get this resistor off then. I might have to try and get some hot air. I'll have to find some sort of shield to prevent it from melting. That might do it. Okay, yeah, let's try my tweezers then. Cool. I think I melted it a little bit. Or it could just be previous damage. No, it looks alright. I don't think I melted it. Everything else looks fine. I'm going to measure this quickly to see if it is wrong resistance, just to make sure it is definitely that. So it's a bit warm at the minute, so it's got to be 2.2. Ouch, this board's still hot. What are we getting? Yeah, we're getting 147 ohms. And that is not this resistor. It's supposed to be a 2.2 ohm. So we're 100% sure that this resistor's gone. And now let me go get the other resistor. And this should be easier to put back on because I don't need hot air. Let's turn that around for my ease. Okay, here we go. Get on that. Ow, 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 it's hot. This board's still really hot. Okay. Oh God. What am I putting it on there for? Complete wrong bit. It's this bit. This bit. Nice. That's that side. And that's that side. Okay. We'll leave it like that. Oh, I don't care about it being dirty at the minute. I just want to show you guys. Is it going to get 5 volts in that little test spot? Sorry, I can't hardly hear myself. I'm wearing headphones. I don't like it. Okay, here we go. Let me plug it in. Damn it. 2 seconds. Where's my ammeter? Up there. All right, are we going to get any different readings when we plug it in? Nope. Okay, it's not drawing anything, but do we get 5 volts at that rail? Going to volt. Good ground. 5 volts. No, we still don't. It's dropping. Why is it dropping now? 0.6, 0.5. We're still not getting 5 volts, so that wasn't the issue. Well, it is drawing something. Oh, it's not now. Yeah. Is that now a short on the board?
Let me make sure that is definitely a 0 ohm resistor. Yeah, 0 ohm. So there should be voltage going straight through it. Voltage, ground, 0.5. Maybe it only receives 5 volts once it's powered up. I don't know. Okay. Carry on troubleshooting. I'll be back in a bit once I find something else. Tracing back where the other 5 volt rail went, and I think it comes from. No, actually, no, that's a lie. If I turn it around, I'm not getting 5 volts at the top here, neither. So I thought, okay, let me go backwards. And we got another 2R2 resistor there. And I measured it, and again, it's in its kilo ohms this time. So definitely that one's failed. This one says 2.2 ohms, but this one's 2 point, I mean, something kilo ohms. I'll show you like on my multimeter quick. So we're getting somewhere slowly. So I'm just going to keep replacing them with 0 ohm resistors because I don't think it's going to make much of a difference. So this is the 2.2. Look at that, we're in the kilo ohms. 0. What's that? 558 ohms. So that's way too high. But then the other 2.2 ohm resistor here, see? Dead on 2.3, almost 2.2. There you go, 2.2 ohms. So that resistor's also gone. It's blown too high. Do resistors blow? Well, I guess they do. So I'm just going to quickly take off that resistor and replace it. Luckily, it's on the top board this time, and it should be okay. Nothing should melt. So let's just go from here. There you go. Okay, now, yeah, looks like the nuts scratched the board a bit. It's kind of dodgy, isn't it? It could have cut through the trace. Never spotted that before. Now we're good though. Now I would want to see what voltage we're getting through the board once it's cooled down. So 2 seconds. All right, guys, I've been looking around for hours and um, I've actually got progress. So I'm not going to take it all apart again, but do you know those 2.2 ohm resistors? Obviously, I changed them for 0 ohms and it still wasn't working. So I looked over my work, and the second chip that I changed, this little one, the one that I originally thought was faulty, there was actually a short. I bridged 2 more pins, and I didn't even see it. And the data lines, the data zero wasn't getting any voltage at all. So I was like, okay, let's just do that. And then, yeah, I undone the bridge, plugged it in, and it kept saying USB not recognized. I thought, hey, up then, here we go. That's a good start. And I kept cleaning the port. So I thought, let me just change cable, plugged it in. It was now it's working. Look at that. Now I've got to put it back together. It's not saying USB device not recognized anymore. Yeah. So happy days. Now it's oh, okay. I don't know why it's going on and off. Is it because of this? Yeah. Okay. You tap that. So at least my dodgy work at the top there's working. Oh my goodness. This took me hours, man. So long. Yeah. Let me get back together and then let's have a look. Exciting. I just wish I recorded it all, man. I was just so much recording all day. I've been at it. It's probably like what 6 hours worth trying to figure it out, trying to trace it all. Yeah. All right. I'll be back in a sec once it's put back together. Okay, and there you have it. Let me zoom out just a smidge. And this is the microphone. Turn off the light. I will give a little sample at the end of this video, but let's see it all light up, looking nice. I don't know how to use it. Go. And to prove that the top still works, there you go, muted, unmuted, muted, unmuted. This is the gain, I guess. And this is to change whatever it's called in there. The gyro, I don't know what it's called, but yeah. So happy days. If you like this video, please give a thumbs up and subscribe. I don't blame you if you don't, because I didn't include everything, which is quite annoying. But in the next clip, this is from this microphone.
Hello, this is Andy Tries Fixing, and today we have just prepared this microphone. I'm going to twist the knob, and now it sounds different. I don't know. I'm going to twist it one more time, and that's the sound it is now. And twist it one more time, and we got this sort of sound, and that's it for it. Now let me twist the bottom here. Does it make any difference? This is all the way down, and this is all the way up. Don't know if it's the gain. I don't know which setting sounds better, but this is the microphone. And yeah, so it seems like it's working absolutely fine.